So started the recording, pretty much saying the same thing again. Some schedule thing. Actually, write it somewhere. So the recording started. So on next week, Friday. Exam 3. I did announce the final exam will be take home, right? It's completely take home, final exam. Okay. And exam review. Review on next week, Wednesday. All right. So there's the quick announcement, and this Friday we'll be doing that homework review, but let's just focus on this problem now. That's what we'll be doing today. It's a very interesting problem. Now this sketch here is a little small, so if I'm gonna make the sketch bigger, then the writing will gonna go like something blurred. But I know the problem, so let me explain the problem, what it is. Okay, on the sketch first, and then we'll read the problem. You see, there is a roller coaster. It starts from point A. When it starts, it doesn't have any velocity, right? So it's like when the roller coaster starts, it starts from the zero speed. You know that, right? So when it started from point A, what happened? The roller coaster goes around this loop and then come back to the C. I mean, actually, it was gonna go further, but assume what happened at C. That's what our interest is. In other words, at point C, we're interested to know the velocity. So that's what we're interested to know the velocity of point C, right? Now, this is a design problem. Here, you are trying to find the value of the h. Okay, h is at what point it should be starting the roller coaster. So, depending on the height of the h, the speed of the roller coaster would be such a way so when it comes to point B, it will not gonna fall from the track. It makes sense? So it's barely hanging. So when it starts from A, depending on the height of the A, because if the height is more, it is going to get more speed. You understand that, right? So depending on the height of the A, when it comes to B, it would be such a way like come at B, it would be such a way like you would be feeling like empty, and floating in the air. Make sense? So that's the problem. So you gotta find that edge. What point the roller coaster should start? So when it comes to the point B, the roller coaster itself doesn't feel any way. So that's the edge you gotta find. And the other thing, as I said, like this velocity at C. Right? Obviously, it will have really high velocity after it rotates and come back at C. And at some point, it will gonna stop, but not here. Probably it will further go. It's just part of the whole loop of the roller coaster, right? That's the problem. Any question? Do you understand this? All right, perfect. I might have some info already. Okay. Let's now go with a little bit detail. By the way, these are in bright space already. So 800 kilogram roller coaster car is released from rest of A. That's what given. You have to find the minimum height of H, this H, of point A, so that the car travels around inside the loop at B without leaving the track. Okay, that's what I'm saying. Okay, also find the velocity at C. Okay, for the height H. Once you find the H, then you can find the velocity. All right, so how are you going to solve it? You're going to first deal with this kinetic and potential energy balance, right, at any 2 points. So you say like when you'll be doing at beginning, solving the problem at the beginning, you'd be considering point A and B, okay, to find one of the unknown. And then you'd be considering point A and C to find another unknown, right? But that's not enough. You also have to this time incorporate the equation of motion, okay? So like one would be comparing 1 and 2, sorry, point A and B. Okay, you have the kinetic and potential energy summation in both sides. You would be equate them, and you would be seeing two unknowns. So to solve two unknowns, you need two equations. The second sort of equation would be the equation of motion. Okay, so just to give you a heads up, equation of motion equal to F equal to ma. You know that, like summation of forces, right? To that equation I'm referring. So yeah, that is the one that you're going to solve, and that's the strategy to solve. Okay, here's one thing that I'd like to highlight. See this gap here. If this is 20, if this is 20 and this is the age, this distance here that you're seeing, right, this distance is age minus 20, and it's so obvious, right, by seeing this, and obviously this is in meter, you can say it's meter. Okay, so that's what important to understand, and then let's start with the problem itself now. So Gibbons. So the mass of the roller coaster is given as 800 kg, right? And initially at point A, there is no velocity. I did explain that, right? And there's another thing from the sketch that you should be looking into. What is the radius at point B? Anyone? 7.5. They call this thing radius of curvature. The symbol they use is what? Rho, right? So that's what I'll be writing. So radius of curvature at point B is 7.5. You can say as a subscript B as well. It doesn't matter that much, but that's what the givens. And the solution, as I said, the strategy is the summation of kinetic and potential energy, right? In A and B, that could be your first thing. All right. So you'll be doing conservation of energy. At point A and B. So you guys remember, like, conservation of energy looks like kinetic and potential energy. You usually use T and V. In last class you've seen that, right? T for kinetic and B for potential. And you are doing it for point A and B. So basically you are doing same thing for the B side as well. This will be TB, BB. All right. Okay. So then here's the thing. So you'd be writing the kinetic and potential energy equation, right, which is half mb square plus mgh bar. Why I'm putting h bar, I'll explain it shortly, but just stick with me here. Okay, so stick with me here. So here, the second one would be mbv square, right, minus mgh minus 20. Okay, why did I write those, and why did I write h bar? I didn't explain h bar yet. So you gotta define the data. You guys done, all of you, fluid class, right? Remember in fluid class, the diagram in Bernoulli's equation. You guys use that Bernoulli's equation. Yeah, Bernoulli's equation. Remember the diagram. Okay, you are preparing in Bernoulli's equation. Everybody took fluid class. Everybody took fluid before. Okay. Yes, you remember Bernoulli's equation. Yeah, okay, it's all right if you don't recall. It's long ago, probably took it. But the Bernoulli's equation, if you see, you're comparing 2-point energy, you have to find the data, right? The reference point. Here, in this case, the problem at point A, if you're gonna think a horizontal line, that's the data. Understand? So that's the h bar. Let's say h bar is 0 that way, right? So at point B, what would be the distance from data? H minus 20, not h bar, right? And point A is h bar. So it's a little difficult to understand, okay? And thinking the datum could be at any point, right? It really doesn't change the problem that much. If you think the datum could be at the bottom, then you're gonna probably have h bar has some value, but you have to understand in the right side, h minus 20 is gonna change as well, right? Make sense? So datum doesn't change the problem that much. But if you think this way, there's the benefit of that. You see, this would be 0 and this would be 0. The first one would be 0 equal to 0 because VA is equal to 0, right? We've seen, as I talked about it, like, at beginning, the roller coaster is at steady state, right? Means it's not moving. So the velocity is 0. Okay, so here's the problem that I would be facing. What is the problem? The problem is we don't have VA and H known. So two unknowns in one equation. M will gonna go out anyway, and we know M anyway, right? So either way, M will gonna go away. So let me put some notes here. So this negative potential energy at point B as the datum is at point A. Because we use the datum as point A, so you see negative potential energy because of that, okay? All right, so now your job is to find the BB, okay? By doing what? By doing the equation of motion. At B, okay? So what is happening at point B? Point B, okay, at point B, let's see if I can draw this sketch. The roller coaster comes like this. This was my point B, right? This was my point B. So what is happening at point B? When the roller coaster is there, as if like it does have a weight, right? The roller coaster does have a weight, mg. Now it's barely on the rail, right? So it's like floating on the rail. So only force acting on this is what, like the mg, the weight itself, right? It will gonna still feel the weight. Okay, but the force due to the weight needs to equate with the acceleration that happened in normal direction. Make sense? Okay, so the normal direction acceleration is v square divided by rho. You remember that? Do you remember v square divided by rho, the normal direction, and tangential is dv dt, right? So the normal direction acceleration is this. So I can write from equation of motion, left side is the force mg, right? So I have this left side, the force, I'd like to stick with the color black as well. So force, normal direction, A and B. Now here's, take a look closely. What I put, like the summation of force in the left side, I put a subscript N. That means I only care about the normal direction at point B, which is referring directly vertical line down. Does it make sense? So that's the reason if my left side does have the normal direction force, that point out the mg or the weight of the roller coaster at point B. Does it make sense? So that's why I can write in left side mg as the weight. Right side, the normal direction expression. You know a way to find it, like v square over rho, right? You know the value of the m 800 kg. So basically, you have pretty much everything except the velocity at b, which is bb, right? Because you know an is v square over rho. Okay, so that's how we're going to find the velocity at b. So let me write it. So you have this left side mg, and you have this right side has a bv squared divided by rho. All right, so then you have this bv, m will going to cancel out obviously. Bv square is rho g, and then you can write this Vv equal square root of rho g. Okay, now you can further write the value. Rho is 7.5 meter and g is 9.81 meter per second square. your velocity will become 8.578 meter per second. At this point, I would say explore equation 1. So from equation 1, find the value of the h. Now this h value would be, let me give you the value, 23.75 meter. I would like you to explore this value of the h. Once you find the value of the h, then you can find the value of the BC. Okay, so for that one, you'd like to do find the BC or velocity at point C. You'd like to do conservation of energy at A and C. Okay, so basically you got to do TA plus VA equal TC plus VC. Remember, this V is not the velocity, is the potential energy, and it should be solved to find the value of PC is equal 21.6 meter per second. So dot dot means this is the thing that you got to do here, right? So many dot dots to find the value of the H. Do it. See if you can get these two values. But I hope you understand already, right? The whole problem. Everyone understand the whole problem, the strategy and everything. You really understand, and this is the rest of the strategy here. Solve to find the value of the H. So what you're going to do to remember here, you're going to find the value of the H. You see equation 1, take a look up there. So the equation 1, left side is 0. The right side has half of mv squared. B is the velocity at point B, which you found it already, right? So your only unknown on that equation is what? H. So if you solve that, you should be able to find the value of the H. Okay? So that's the first part. Once you have the H, then solve this one to find the other velocity. Okay? If you have those two answers matched, that means you're done for today, you can go. If it doesn't match, then stay here, I will help you in person to solve it. How many of you have the value of the H already? Yeah. 1, 2, 3, 4. Brad and Joe is still doing H value. Do you know you have the H value already? Not yet. You got this idea how to solve it, right? I don't want to interfere because this is a simple math. You understand like the GA, BA, right? Yeah, that's the way. That's the way. Exactly. You got equation. You can go now. You will less than half an hour. Okay. So that's the reward. You finish early, you can go. I'll see you on Friday. Friday class will be probably a little longer because I gotta deal with homework and a new chapter. I don't know, maybe I'll start the new chapter early and do the homework. We do have time. We are almost done with the main agenda. The final chapter we just have to do the rest of the semester. Okay, then. You too. Oh, I got to do the grading as well. I forgot about it. Yes, I've exam two already. Does you understand the problem? A good day. Where do you find the H value?
Yes.
Joe, you found H value?
Yep.
All right, let me finish the H so everybody is with us. Okay, so to find the H value, what you got to do? You got to write equation 1. So what do you have in equation 1? Equation 1, we have this left side has 0, and right side we have half of mbb square minus mgh minus 20, right? So this m will gonna go away because in left side we have 0 and right side both has m. This is not gonna go away, so I can rewrite this whole thing again, half of bb square minus gh minus 20. Okay, we're strictly with the algebra still. Let me move this negative gh minus 20 in left side, and we have half of bb square. So then we have h minus 20 should be equal bv square. I'm just rearranging things, right? And that's the way I like to do things, so the chances of error are minimum. That's what you learn in intro to engineering class anyway, right? And then you're going to start to plug the values. So 8.55, is it 58 square, 9.81 plus 20, and the whole thing unit is meter. If you do the math, the h value would be 23.75 meter. Okay, giving me some time to finish that PC. Do you know you are done with H? Just about. Almost. Okay, it could be helpful the thing that I wrote here. If you are having different value, in that case. All the thing I did here, I'm rearranging. I'm just redoing the calculus. This simple algebra. I'm rearranging things. Means like this negative gh minus 20 thing. I moved it to the left side, right? And then I moved the g to the right side. And I moved the 20 to the right side again. And finally I plug all the values to find the value of the h. Okay, for the next segment, what I'll be doing, I'll be writing the equations, right? So I do have this left side has, like, remember both the kinetic and potential energies are 0, right? In the left side at point A. So I'm rewriting that this way, half of, and the right side, I'm going to write the kinetic as like half of mbc square. Okay, and here's the catch. So I got to write this thing as negative mg h. Why did I put negative? Just same reason I put the negative for a and b comparing, right? Because the g is acting down, and other way you can think it that the h bar is at point a, so h is negative at c. Either way it will gonna work the same thing. So you do have this half of mbc square, where bc is what you're trying to find, and mg is in the right side. I just move things here and there. M is gonna get cancelled out, so bc square will be gonna become 2gh, and this bc should be square root of 2gh, and then you'd be plugging the value of 9.81, and the h is 23.75, right? Meter. That's your bc, and this bc value will gonna become 21.6 meter per second. That's your final answer. Okay, so to do a quick wrap up on this problem, the problem was given with the mass of the cart or the roller coaster is 800 kg. The row or radius of curvature is given as 7.5. Okay. They asked you to find the minimum height h, so the roller coaster is not gonna lose the track at point B. Okay, so we take the consumption of the energy at these two point A and B, and take the equation of motion at point B to find the h and the velocity at B. Once you add those, then you take the conservation of motion again at point A and C to find the velocity at C. Okay, so that's the problem. If you have any question, you can ask me. Other than that, you guys have a good day. I'll post it in Brightspace, and I'll see you on Friday again. You too.